Hello and welcome. We've talked about generics in general, kind of how Java implements them. We now want to talk about how Kotlin implements generics. Luckily, it's very similar to Java, so we're going to end up repeating some of the concepts I talked about in the previous lecture, which is good because it just means it's easier in Kotlin, right? And it's similar to Java. So generic classes, Kotlin's generics are fairly similar to those in Java. You would declare a generic function or a class in the same way you do in Java. Classes in Kotlin may have type parameters. They're also referred to as container types in Kotlin because of the close association with collections. Right? We know that collections are implemented using generics, and because collections are such a focal point in Kotlin, generics are referred to as container types. To declare a parameterized type, we can use the angle bracket syntax just like we do in Java on the right-hand side of the type name and put the type parameters in angle brackets. So you can use the type parameters in the body of the class just like any other types. Again, similar concepts to Java. Well, actually the same concept as Java, right? How do we identify a generic class in Kotlin? The same way we do in Java, we see those angle bracket syntax. It's after the class name. And then the type parameters go inside the angle brackets with more than one type parameter separated by commas. So here's an example, simple example, class sequence, Kotlin class, and then we have, after the class name, we have inside angle brackets the T. And we use the same generic naming conventions that Java uses. Remember those single uppercase letters? Same thing here. And because this is a class that takes a generic, we just say T. You can declare more than one type parameter, as I mentioned, using the commas. You could say class dictionary. Here we're using K and V because a dictionary takes a key and a value, takes multiple parameters. Remember, we use different uppercase letters. So class dictionary takes a K and a V for key value, separated by commas, are angle brackets. You can also declare a typed parameter with the primary constructor. So here we have box Kotlin class. We have T inside our angle brackets, and then we have our primary constructor. T for the name of the field property, and it takes the type of T. That will automatically initialize the type and have a getter and setter for it. We could also assign a variable value equals T. So it looks very similar to Java. Nothing really different so far, just the Kotlin syntax, right, with the class names and so forth. And the colon for the names, for type names. To create an instance of such a class, how do you use it? You need to provide the type arguments. You have to fill in that type when you instantiate it by replacing the parameters with the actual type. So just like you created the lists, same type of thing. We have our variable called box. It's a read-only variable. It's of type box with angle brackets int. And so we don't have to use the new keyword like we do in Java to create an instance. So we just say equals box int, and then we're passing in a parameter there, 1, for our box int, our constructor there. So it looks very similar to other ways we create instances in Kotlin, except we have those angle brackets. We have to specify the type inside the angle brackets. The parameters may be inferred, and some type arguments can be omitted. We know type inference means that the compiler is able to understand what type it is. So you can infer from the constructor arguments, or some other means, what type it is that you're defining. So you don't always have to declare the int inside the brackets if the constructor can infer it. So in this case, we wouldn't have to say box int. 1 actually infers through the constructor that it's an int, so you can just say val box equals box of 1. Now, the angle brackets is good because it's easier to understand that you're using a generic. But if that class is abstracted and you don't need to know those implementation details, you can just say val box equals box 1. The compiler will automatically know that you're passing an int as the type for this generic class. Generic functions. Functions can also have type parameters, just like in Java. The type parameters are placed before the name of the function. Because remember, in Kotlin, the return type is not placed before the name, right? In Java, we placed the type parameters before the return type. But in Kotlin, the return type is at the end, right? We do the colon and then that's the return type. So for Kotlin, you just have to put the type parameters before the name. So for example, if we have a function called random that when given some elements returns one element randomly, we do not need to know what the types of the elements are. This function would have a single type parameter and would be a perfect candidate for declaring it as a generic function. So we could implement it this way in Kotlin, which is really kind of silly. We have a random function and we have 1, 2, or 3 that takes any types. Any is the base class. Every object in Kotlin is a subclass of any. So technically you could do this, and this would accept any type because every subclass is of type any. So you could define it like this, and you could say it returns any, but this is kind of foolish. You'd probably want to use a generic. It's also very limited because the return type would be referred as any, and then you'd have to cast it. So if you tried to use the random function and you were passing in strings, and then you wanted to cast, you'd have to cast it back to a string if you wanted to call string functions on it. So you'd have to cast it back to the original type. It's error prone, not to mention not very clean. So it's much better to use generic functions in this case. You can write the function better using a type parameter. Use the angle bracket syntax. Inside the angle brackets, specify the type, and then before the function name you want to put that. So here we have function. We know it's a function because the fun keyword. We have the angle brackets. Here we have t, it's returning a type. We have the name of the function after the angle brackets, random. And then we have 1 colon t, 2 colon t, 3 colon t. We have 3 named parameters, 1, 2, and 3, that all are of type t. And it also returns a t because after the colon in the right parentheses, we're saying returning a t. Now we can implement that random function however we want it, just like a regular body. So in the above, we have defined a single type parameter t, which we can use for all 3 parameters and the return type. This is informing the compiler that whatever type we fix t to be, we return that same type. So if we pass in a string as the type, it's going to return a string. If we pass in an int, it's going to return an int. Whatever object we pass in, it's going to return. To invoke this function, you don't need to do anything other than pass in instances. So you specify the type arguments at the call site after the name of the function. For example, you say random greeting string. You say random and you pass in 3 strings. And that's going to automatically return a string. You don't have to cast. You don't have to do anything. You can call that function without using the angle brackets. You only have to use the angle brackets when you create the classes if it can infer the type from the constructor. But from the function, you can automatically, you're passing in strings, it can automatically infer that type. So that's nice syntax right there. Writing less code. You could, if you wanted to, also do the following. You could create an any type and then say random a, 1, and false. And what this would do is, how's it going to return, right? It's not going to, you're passing in 3 different types. A string, an int, and a boolean. And so how can you return that? Well, you can return it because it's returning an any type. So that's a little strange there, right? Because you're passing in 3 different types and you would expect it to return the type that you pass in, but they're 3 different types. Well, because you say any, that will work. Because any, again, is that top level class. Everything is a subclass of any. Functions can have more than one type parameter, as we mentioned. So here's an example of a function called put. Before the name of the function, we specify the type parameters. Inside the angle brackets, here we say k and v because it's a key and a value. We specify for the named parameter key that it's going to be type k. For the value, it's going to be type v. We're going to return a unit, which is a void type. So the above signature is commonly used with collection classes because collections take key value pairs, some of them. You can also declare type parameters on top level functions and extension functions. So now you don't only have to make functions inside classes generic, you can make top level functions and extension functions generic. So here's an example of extension function. We know it's an extension function because we have the extension function name there, right? t.basic toString. If it wasn't an extension function, we wouldn't have that t dot. So whatever type you pass in here, it's going to be an extension function for that type, and it's going to return a string, and that's an extension function. Generics at runtime. Generics on the JVM are normally implemented through type erasure. What this means is that at runtime, you don't know the type. So type arguments of an instance of a generic class are not preserved at runtime. And this can be a problem, right? Especially for polymorphism and things like that. This is the same way that Java implements that. Type arguments for generic types only exist at compile time. So you can't use types with type arguments together with the is operator. You can't check types. You can't do any. You can't say, is this an instance of, or is this a subclass of this on a generic? It won't work. Now, type arguments are erased at runtime, as we mentioned. There is a workaround, however. If you want to make the generics be able to use the is operator, you can have the type parameters as inline functions, and then you'll have to mark them as reified. So this allows you to use them at runtime to perform is checks. It allows you to do this checking of is if you specify the function as reified in inline. This is a workaround. I don't want to spend a ton of time on this. It's more of an implementation detail, but there's specific reasons why generics do not maintain their types at runtime, mainly performance reasons. So they have this concept of type erasure, and it can cause issues. So Kotlin added this thing called reified, which you really need to know the type, and you really need to use the is operator. Mark the function as reified and as inline, something like this. Inline fun, say reified t is a value any, and then you can use the is operator. You can say value is t. And then you can print it out, and you can say is a string, and it will tell you the type, and it will check it at runtime. It will say true. And in this case, it would say false if you didn't pass in a string. Is a string. I wanted to mention this again because you may need to do it at some point. You may need to mark something as reified to use that is operator. Let's look at a couple examples inside IntelliJ. So first, how do we know that our collection classes are generic? Well, you could just write a simple test, right? Let's create a list here. And we're going to create a list. Sorry. We're going to create a list of characters. We're going to convert just a bunch of characters, all the alphanumeric characters. We're using a range here, ... All of the alphanumeric characters we're going to convert it to a list using the toList function. It's going to be contained in a variable called letters. Now, we know this is generic because we can call the slice function on a char, or we can call it on a number. So this slice function is going to take a generic. So if we build this and we run it, we'll see that it works on both integers and characters. We can slice it on characters. Slice will just remove elements. 0 to 2, it's just going to grab the first 3 elements of chars. And slice will take the 10 through 13 elements here, and you don't have to pass in the type. Let's see how we can create a generic function. Let's create a generic extension function. We know that we can create a function generically by specifying the type parameters before the name of the function. So here on line 2, I'm going to create a generic function, and we have the angle brackets, and we have t inside there. We're going to make it an extension function because we have list here dot. So this is going to be an extension function of our list interface. And we're going to use t as the type for the list, because remember, lists are generic themselves, so they have to take a type. The extension function that we're creating is called penultimate. It's going to return the type. So this is an extension function that's going to just return the second to last element of the collection. So all we have to do to implement this is we can just use the get function on the collection, and we can just get and return size minus 2. We can directly access, remember the list you can access directly through the index. So we're going to return size minus 2 of the index, and that's going to return the type. So this is an extension function using generic. So now we can call this with different types. Here we're going to print out the list of integers, the penultimate list of integers. So if I run this, it's going to print out 3, because 3 is the list. If I ran this with strings, it would do the same thing. Print out the penultimate. If I can pronounce that correctly. So now it should print out Mike. And it does. So a simple example of creating a generic. Pretty easy. Let's also look how we can use the is operator. Remember before I mentioned that if you had a generic and you wanted to use the is operator, you'd have to define the generic as inline and also using a reified keyword. Here's an example where we can check. I wanted to make sure you didn't get confused that you can still check a collection type using the is operator as long as you already know that type. So here in this example, we're creating a list of integers, passing them into a function called printsum. We know the type. This is not a generic, right? Even though the collection is a generic, this printsum only takes integers, collections of type integer. So what this means is we can use the is keyword on it, and we can check the type of it. This is different from having a generic that you don't know the type. You would have to create that as inline. So let's try not to get those confused. In this case, you would know that this is an integer, and it would actually work and print out the sum, which is 6, because it's a collection that takes a specific type ints. If we change this and it were to take, t's, it wouldn't work. Okay? We wouldn't be able to check at runtime whether or not this worked. Now, if we want to create a function as inline reified, we'll be able to check the type of it using the is operator. So you can do that, as I mentioned, just like you can from the lecture, is you can create a function. You have to mark it as inline, and you have to say reified with t as a type, and then you can use the is value is t. So if we were to run this, it will check at runtime the type, and we'll see if the type is correct. So let's run this, and we're going to check if the ABC is of type string, which it says true. If it's of type string, when we pass in 1, 2, 3, it's false. So we're using the is operator on a generic. It's going to return t. So it's checking is of t. The parameter we pass in is going to be any subclass of any, which is a string or anything else. Now I wanted to show you one other thing. There's a nice function inside of our collection classes where you can check the type. So you don't have to declare everything as reified if you just want to check the type of a string inside of a collection. So I want to create a list here called items. It's going to have 3 different types, 1, 2, and 3, or 2 different types. It's 2 strings and an int. There's a function called filter is instance, which can filter based on type, which would use the is keyword somehow. So we can say items.filter is instance and pass in a string, and it will check whether or not each element is of type string and return those. So if we run this, you'll see it returns 1 and 3. So you're filtering on the instance of strings. That's just a nice helper that you can use if you want to write an inline and you want to use the is operator to just check the type of objects in a list. Well, you don't have to do that. You can use filter as instance. So just an introduction to the Kotlin syntax for generics, how you can create generic functions in Kotlin, generic classes, very, very similar to Java. Really the only difference is a little syntactic differences. Thank you.